you are here. First of all, welcome everybody. My name is Robert, and you're here for a master course on traffic, but I'm not going to talk about that just yet. As people are coming in, we have a special guest today, and I want to make sure everyone understands the controls here, because once I turn this over to our special guest, I'm going to let him roll, and then towards the end, I'll come back on camera. I'll be asking all the questions that you guys have in chat, but to get to that point, you're beautiful. You're beautiful. I know. It's okay. But we have Crowdcast is our platform. There's a couple buttons that you see on the bottom. First is ask a question. Go in there, ask your question, vote up, vote down those questions. We have a chat. Say something nice, and say where you're from if you feel comfortable with it. Lastly, we have a green button on the bottom right below us. It says join the SUSE and Rancher community. Click on that button towards the end, obviously, and join the community and continue the conversation that we're going to have today. But enough about me. This is more about our guests. Ladies and gentlemen, I want to welcome back Adrian Goins. Adrian, the floor is yours, sir.
Hi. Well, so my name is Adrian Goins. I am so happy to be here. So I'm the head of developer relations for Traefik Labs. In a previous life, I was the director of community and evangelism for Rancher Labs. And although I'm not at SUSE anymore, I still bleed Rancher blue. Now, I am excited to be here today with all of you, and I hope that you're excited too. You're going to walk out of here with knowledge that you can use today to start taking control of traffic proxy in K3s or in I pressed the wrong button. I have buttons. If you've ever, let me jump back to here. If you've ever watched me stream or do anything, I have like an iPad Pro, a monitor, a camera, a teleprompter, another monitor, a computer, lighting. So yeah, so this is going to be a fun production. That's me. You don't need to copy that information down. I'll show you that slide at the end again, and hopefully by then I'll have earned your trust? Who knows? So we have a lot to cover. I'm going to start with a highlights tour of K3s and Traefik Proxy, and then we're going to jump into the deep end, first with a detailed look at the engine of Traefik Proxy, and then with a complete end-to-end example of using Traefik Proxy to expose and secure an application. Now, since demonstrations are always a little bit contrived, I'll follow that with a real-world example of how I'm using Traefik Proxy in my Kubernetes clusters. We'll spend a little bit of time talking about troubleshooting, and then we'll have a Q&A session and wrap it up. So like Robert said, if you think of a question, post it in the questions panel, and we'll try to get to those at the end. We have 90 minutes scheduled for this webinar. I think that my demonstrations and stuff will be done in less than an hour, so that leaves lots of time for Q&A. Are y'all ready? So let's get started. K3s. K3s is the lightweight open source Kubernetes distribution that's designed to work on premises and in the cloud. It's tiny, so you can use it in resource constrained environments like IoT and the edge, and it's fast, so you can use it in places where you don't need all the baggage that comes with a full-size Kubernetes distribution. How many of you remember when you would get a toy for Christmas and it came with batteries included? I don't even know if they still do that. I don't have kids. But at the time, for me, that meant a lot because you could immediately start playing with it. So K3s is the same way. Everything ships as part of a single tiny binary, and that unpacks to include containerd, Kubernetes, and manifests that install the open source software that you need to use the cluster right away, like Traefik Proxy as the Ingress controller. You don't have to prep your hosts in any way, and K3s installs practically anywhere on both ARM and Intel architecture. Basically, if you can put Linux on it, you can probably run K3s there. K3s was originally created by Rancher Labs, and then it was donated to the Cloud Native Computing Foundation. It's the only Kubernetes distribution that the CNCF owns, and that says a lot. You see, the act of donating something to the CNCF isn't like walking by and just throwing it over the fence, being like, peace out, it's yours. The CNCF reviews submissions, and then they choose what they accept. So by accepting K3s, they've told the world that this lightweight distribution of Kubernetes has a place in their landscape of cloud-native applications, and that its existence serves the community. So while there are other lightweight Kubernetes distributions like MicroK3s and K0s, every time I see K0s, my brain says chaos. I don't want to run a Kubernetes distribution called chaos. But only K3s has the CNCF's stamp of approval at this level. So back to the batteries included bit. K3s has 4 special features. Let's call them pillars. And these are working for you out of the box. These are the service load balancer, called Clipper, the manifests directory, CRDs for Helm, and Traefik proxy. The service load balancer is an open source project called Clipper that's part of the overall K3s project. When you deploy a cluster into a cloud provider, the cloud controller manager communicates with the cloud provider's API, and when you request a load balancer service, Kubernetes provisions a cloud load balancer for you. The cloud provider then bills you for this resource until you destroy it. When you run Kubernetes on premises, you have to use an external load balancer of your own, something like an F5 Big IP or a NetScaler, or an external box that you build running something like Nginx or HA proxy or even Traefik proxy. Some commercial providers will give you a cloud controller manager that you can run in your cluster that talks to their hardware, but in most cases, you'll be doing double work. You'll configure something in Kubernetes to listen on a port, and then you'll go and configure the load balancer to send traffic to that port. Remember that K3s is Kubernetes for resource-constrained environments first. So it's optimized for single-node clusters. It uses SQLite as the data store, and when you create a load balancer service, Clipper opens those ports locally on the cluster nodes. From the moment that you fire up a K3s node, Clipper makes sure that you can connect to Traefik proxy listening on port 80 and 443. The way that K3s unpacks to be so powerful is that it includes manifests that are placed into a special directory on the server. K3s monitors this directory, and if it sees something new there, then it installs it. If it sees that an existing manifest changed, then it updates it. It won't uninstall stuff if you remove it. It just installs things and then updates them. This is a great way to bootstrap a server with a configuration management system. If you create that directory before you install K3s, then in addition to installing its own resources, K3s will also install whatever you tell it to. You can use this after installation as well. You just drop new stuff into that directory and K3s installs it for you. Installing via manifests is one thing, but installing via Helm is the standard way that we do things in Kubernetes with large complex packages. So how do you automate what's normally a command that you run from a terminal? K3s gives you the Helm chart custom resource for this. When you convert your Helm instructions to the format in this manifest, K3s installs the packages using an internal Helm controller. And once installed, you can see and interact with them exactly the same way as if you installed them via the command line. For complex Helm values, or to alter a Helm chart resource that ships with K3s without altering the manifest itself, you can use the Helm chart config custom resource. This is how you would, for example, change the static configuration of Traefik proxy in a K3s cluster. And of course, the final pillar that K3s includes is Traefik proxy. This is a powerful cloud-native edge proxy that can do tremendous things for you. It's what we're going to talk about here today, so let's dive in and see what it can do. First of all, just like K3s and Rancher and all the other software that we love, Traefik proxy is open source. Many of you have come across it in the past, and it was probably when you were starting out and working directly with Docker. In fact, if you look online, you'll find that there's a lot more documentation and videos and courses about how to use Traefik with Docker and Docker Swarm than there are about using it with Kubernetes. But guess what? I'm here to change that. Like K3s, Traefik proxy works almost everywhere. It works with Docker, Kubernetes, HashiCorp Nomad, Consul and Consul Catalog, Amazon ECS, Marathon, bare metal with configuration stored in files, key value stores, or databases. It even works with Rancher 1.x. But if you're still running 1.x, please, please, please upgrade. The power of Traefik proxy comes from its dynamic configuration, which means that it monitors the environment in which it's deployed, and it automatically picks up services and builds the configuration for how to connect to them. These building blocks of all the components are there for you to wire together. Now that flexibility has made it very popular with over 2 billion downloads, nearly 37,000 stars on GitHub, and hundreds of thousands of nodes in production. And because it's so dynamic, it works the same with every provider. Once you learn how to use Traefik proxy, you can use it in any environment that you want. Many companies are still using Docker Swarm, but they want to migrate to Kubernetes. Well, they can use Traefik proxy in both environments and make the new environment just a little bit more familiar. One of my favorite things about Traffic Proxy is that it doesn't terminate in-flight connections during a configuration reload. So short of upgrading the pod where the old pod actually terminates, Traffic Proxy will seamlessly update its configuration as the backend environment changes, and clients will never know that anything happened. Now, some of you are probably like, well, that's totally obvious, right? I mean, how terrible would it be to cut off communication with someone who's interacting with your service just because the ingress controller received a new configuration? I used to also think this way until I learned that what I just described is exactly what Ingress Nginx does. When the configuration of your cluster changes, Ingress Nginx creates a new flat file configuration and then signals itself to load it, and in doing so, it will terminate all active connections. When I learned this, I dropped Ingress Nginx like a hot lump of coal, and I haven't used it since. Did you know that Ingress Nginx, as long as we're talking smack here, did you know that it also has a truckload of unresolved security issues? Rancher has a hardened version of Ingress Nginx that's used by RKE2, and when scanning that image for vulnerabilities, let's just say that there's a lot of them, at least at the time of this, and if you're watching this recording in the future, it's probably still going to be the case. A similar scan of Traffic Proxy turns up 0. So if Traffic Proxy is so amazing, and if it's included in K3s, why don't you hear more about it? The honest answer is one that all of you already know, and it's why you're in this class. Because Traffic Proxy works in so many places, its architecture is different from other ingress controllers, and that can make it confusing and hard to start using it. Let me jump back to the camera here. So I ran into that myself. There were multiple times over the last 3 years that I wanted to start using Traffic Proxy. Usually it was while I was building a new cluster, and when I couldn't just intuitively understand how to set it up, I defaulted back to something else that I already knew. If we were in an auditorium and all of you were sitting here, I imagine I would see a lot of you nodding your heads. So it wasn't until I committed to learning it and I worked through the ways that it solves problems that I was able to say, oh, wow, okay, now I get it. And this is actually really cool. I've taken all of that and I've put it into this class. And by the end of it, you're going to understand Traffic Proxy and you'll be able to start using it successfully in your environments today. But buckle up, because we're about to take off. This section is the most important part of this class. It's very important to understand the names of the components of Traffic's architecture and what they do. So we'll start with the configuration. And there are 2 types in Traffic Proxy: static configuration and dynamic configuration. Static configuration is attached to the software at startup, either by environment variables, command line arguments, or a config file. Something that trips people up when they start out is that only one of these can be used. The configuration file has the highest priority, followed by command line arguments, and finally by environment variables. In your environment, just pick one and just stick to it. Don't try to swap between them. Traffic Proxy on K3s uses CLI arguments, so you can see those if you look at the deployment of the pod manifest. Static configuration tells Traffic Proxy what entry points to use and which providers to enable. You'll understand those terms in a second. An entry point is a port where Traffic Proxy listens, and a provider is a backend provider like Kubernetes that Traffic will pull for updates to the configuration. Now, when I said you'll understand those in a second, I didn't mean literally in a second. We're going to discuss entry points and providers in greater detail in a few more seconds. When one of those providers reports a change, Traffic Proxy updates its dynamic configuration. The internal objects that Traffic Proxy creates in its dynamic configuration are routers, services, middleware, and certificate stores and options. There are many providers, and they aren't all enabled by default. In the case of K3s, only 2 providers are enabled: Kubernetes Ingress and Kubernetes CRD, which is the custom resource definition provided by Traffic Labs, and which we'll also review later in this class. For now, just know that enabling a provider tells Traffic Proxy to pull that provider for information and to use that information to assemble and maintain its dynamic configuration. Usually, you only activate the providers that correspond to the environment in which Traffic Proxy is running. Makes sense, right? A provider fits into one of 4 categories that determine where in that provider's resources you put the configuration for Traffic Proxy. For example, the Docker provider is label-based, so you would put Traffic's configuration into labels in your Docker Compose file. Traffic picks up these labels from the Docker API and builds the dynamic configuration. The Kubernetes Ingress provider is annotation-based, So you would annotate the ingress or service resources in your cluster, and Traefik would, what would it do? Raise your hands, shout it out. It would pick up that information from the Kubernetes API, and it would build the dynamic configuration. Besides the label and annotation types, you have key value pairs that can be stored in something like etcd, Zookeeper, or Console, or you can use files, which is what you would use if you had Traefik Proxy running on bare metal. The Kubernetes CRD provider, I think, is technically a file-based provider because the entire manifest represents a component inside of Traefik Proxy. You could, if you wanted, add files as config maps inside of Kubernetes and attach them as volumes to the Traefik Proxy pod. You could then use this to enable Traefik Proxy to work with services outside of the cluster while also working with Kubernetes services. With the dynamic reloading of config maps inside the pod, Traefik Proxy would pick up the file changes and then update the dynamic configuration. In Kubernetes, we use namespaces to prevent name collisions. Service foo in namespace alpha is completely different from service foo in namespace bravo. Traefik Proxy has a similar architecture for its providers, and when you want to reference a resource in a different provider, you include its namespace with an @ For example, if you were working with an Ingress resource and you wanted to reference a middleware named Middleware Redirect that you created with the Kubernetes CRD provider, you would call it from the Ingress as Middleware Redirect at Kubernetes CRD. If you wanted to use that middleware from within an Ingress Route resource, which is already part of the Kubernetes CRD provider, then you would just reference it as Middleware Redirect. No namespace required. This lets you reuse resources and mix and match providers. Maybe your middleware is stored in an etcd or Zookeeper data store so that it can be used by Traefik Proxy that's running in Docker and in Kubernetes. Do you see how you can start to assemble a modular system that serves your entire environment? An entry point is the port where Traefik enters Traefik Proxy. And I apologize for the traffic. We run into this with Rancher Labs, but that's why I always say Traefik Proxy instead of Traefik. It makes it a little easier to get the context. So here we go. An entry point is the port where Traefik enters Traefik Proxy. That's it. It's a port. But what's special about it is that it is protocol independent. Have you ever tried to send an HTTPS request to port 80 or to send a plain HTTP request to port 443? Or maybe a better example is if you want to serve HTTPS on port 443 for one site, but you also want to pass it through as straight TCP for another site. You can't do that with a normal ingress controller. You have to terminate TCP on a different IP address, or else you have to terminate TLS and then forward it as TCP, and you forfeit all of the layer 7 stuff that you might want to do for HTTP transactions. Generally, we associate ports with protocols, because if you have a web server listening on port 80 or port 443, you know that it speaks HTTP or HTTPS, and that's it, right? This isn't true with Traefik Proxy. The port is just the port. You could configure Traefik Proxy to receive HTTP requests on port 443 and redirect them to HTTPS on port 443. You could have it process HTTPS traffic on 443 and also pass through TCP traffic to a backend that has its own TLS certificate. You can do whatever you want with it. And starting with Traefik Proxy 2.5, we're on 2.6 now, but starting with 2.5, we've also enabled HTTP 3 requests. Next up, we have a router. A router receives a request, analyzes it, and connects it to a middleware or a service. I'll say that again. It receives a request, analyzes it, and connects it to a middleware or a service. So once traffic enters on the entry point, it's received by a router. The router looks at the protocol, path, hostname, and TLS configuration, and then it decides what to do with it. If it's a TCP router, then it just passes it through, maybe doing TLS termination or whatever. If it's an HTTP router, then it can make decisions based on SNI header, path, hostname, and other layer 7 attributes. In its default configuration, a router passes the request to a service, but it can also pass the request to middleware. Middleware alters the request before handing it off to the service, or if it's outbound traffic, before handing it off to the router. It sits between the router and the service, but it's an optional component. Middleware is how you make your Traefik Proxy installation into a beastly powerhouse of edge processing. Middleware exists for local and forwarded authentication, for compression, for rewrites, redirects, buffering, circuit breaking, rate limiting, retries, error handling, and more. You can chain middleware together so that a request passes from one to the next before continuing on its way. A service connects a request to the backend servers. This is the final piece before a request exits Traffic Proxy and goes to a backend server. Services handle load balancing configuration like session stickiness, mirroring, weighted distribution, Canary testing, and blue-green deployments. In Kubernetes, we think of the Kubernetes service as handling this piece, but the real value of a Kubernetes service is to provide a stable hostname and IP that maps to a group of pods. Traffic Proxy has a much more comprehensive configuration for load balancing than a traditional Kubernetes service, so it only uses the service to get the list of healthy pods behind it. Technically, it uses the endpoint. It then sends traffic directly to those pods, and it bypasses the Kubernetes service entirely. And if you think about it, squeaky. If you think about if you think about it, this makes sense. We don't want Traffic Proxy to load balance one IP address that in turn load balances the actual IPs with a different algorithm. We just want to go directly to the pods themselves. Each custom resource in the Traffic Kubernetes CRD maps to a traffic object. An ingress route is a router, and there are three types. There's ingress route for HTTP and HTTPS, there's ingress route TCP for TCP, and there's ingress route UDP for, in the back, that's right, UDP. A traffic service is a traffic HTTP service. It's not a Kubernetes service. And if you're not messing around with mirroring or session binding, then you can just use a Kubernetes service as the target in your ingress route. But as soon as you want more control, you'll switch to using a traffic service. A middleware resource maps to middleware. That one's easy. And there are additional custom resources for configuring TLS options. These map directly through to the traffic objects of the same name. We won't get into those in today's class. Traffic Proxy can do other things that we also won't get into today, but I want you to be aware of them. It comes with support for dynamic tracing with Jaeger, Zipkin, Datadog, Instana, Haystack, and Elastic. In fact, I just did a webinar last week with Instana where they showed how to use Traffic Proxy with Instana to monitor all sorts of crazy stuff. It will expose metrics that you can use with Prometheus, Datadog, InfluxDB, and StatsD. And it can also ship common logs to a file or to standard app. And these are off by default. In fact, all of them are off by default. But if you turn them on, in case of common logs, you can get your logs in common log format or in JSON. It also comes with a dashboard that shows you the dynamic configuration, the available providers, and what additional features are active, like tracing and metrics. The dashboard is read-only, but it's very useful to see what Traffic Proxy knows about your environment so that you can configure your resources to wire those objects together so that others can consume them. For security reasons, the dashboard is not exposed outside of the cluster, and we are going to spend the rest of this class using it as a sample application to demonstrate everything that I just explained before. First, we're going to expose it via port forwarding. Then we'll put it behind an ingress. Then we'll use middleware to secure it with basic auth and rewrite the URL. As we do that, you'll see that working with ingress objects is a little bit clunky, so we'll redo it with an ingress route. Finally, since we can't be passing credentials around over HTTP, we'll use Cert Manager to secure the whole thing with a TLS certificate. The easiest way to access the dashboard is to forward port 9000 with kubectl. So let's do that. Oh, where's my mouse? When you're going to the dashboard, you have to append dashboard slash. And let's blow that up for you a little bit. The trailing slash is important. So this is the traffic dashboard. You can see a nice overview here of your routers and services and middleware for HTTP. And I must comment on something. There's a debate going on about whether it should be middleware or middlewares. I always thought of it in terms of software. We don't say softwares, but actually the dictionary doesn't clearly define whether it's acceptable to say middleware or middlewares. I wish we had set up a poll for this. We could get your all's opinion about it. But I'm just going to say middleware. When you see middlewares, whatever, now you know the story. So you can see all of the routers, services, and middleware for HTTP. For TCP and UDP, we don't have anything there. If I were to click on the router, you can see that these are the routers that are set up by default, the entry points that they come in on, and the services to which they go, and then what provider they're using. So over here on the right, for the first one, you see that it's using the Kubernetes provider. You can also look at services. There's no middleware available now, and so you can click around on these things. Accessing it via port forwarding is actually fine if you don't use it very often, but as soon as you want regular access to it, then it makes sense to actually expose it. The Kubernetes Ingress provider is annotation-based. This means that you configure Traefik proxy through annotations on the ingress as the Traefik router, or on the service as the Traefik service. And annotations look like this: traefik.ingress.kubernetes.io/router.entrypoints, web secure. And then you could also have router.tls true, which would activate TLS. You can get a list of all of the annotations from our documentation. Everything that I'm doing today is in a GitHub repository that you can follow along with. I'll actually leave this up for just a moment, and maybe Robert, you can copy that and paste that in the chat. So I am working on a single node K3s cluster that I installed just with the defaults. So you can go to this repo, clone that, and you can follow along, either now or later if you're watching this as a replay. And yeah, there's actually readmes in there that are more or less what I'm saying in this entire thing. So, clone that and we can play. Because we are all working in different environments, I'm using sslip.io for the host name. And throughout the documents, you'll see me use a variable cluster IP that I'll set now to the IP address of my single node K3s cluster. For me, that's 1068.070. Let's kill that port forward, and let's set that. And what this does is it means if you're following along in the readmes, once you set cluster IP, you can actually just copy and paste everything. The port for the Traefik proxy dashboard is not included in the default Traefik service that's created when Helm installs Traefik. So you can see here, we only have 80 and 443. The dashboard listens on port 9000. So we need this as a target for our ingress, and in order to make that available, we'll create a new service. So we'll just expose the Traefik deployment, port 9000 to port 9000, and we'll call it Traefik dashboard. With the service created, we can create an ingress that actually exposes the dashboard outside of the cluster. And I know somebody is going to ask, what is this thing on the right side of your terminal that allows you to double click? I'm using iTerm 2 on a Mac, and it has a thing in its toolbox called snippets. So I just took all of the commands that I need for this class, and I just put them in there in order so that I can just double click on them, and y'all don't have to sit around and wait for me to type things. So now, with that exposed, we can come over here and that should have worked. Should not have gone to, oh, I know why. I have a 301 redirect that my browser remembers from testing this. Oh, terrible. Oops, and we need /dashboard. Okay, so directly going to HTTP, well, there we go. So now we just went to dashboard.traefik.myip.sso/dashboard. And if we look now, let me blow this up again because it's a different URL. Now if we look under routers, you can see that we have down here at the bottom our ingress. Now what do you notice about the entry points? And I kind of already gave this away because you saw that the redirect happened. But yeah, so it's listening on both web and web secure. We can send an HTTPS request to port 443 and we'll get an invalid certificate error. So let's just do that since we're here. There we go. And if we look at the certificate, you can see that it's actually the Traefik default cert. Sorry, that's a little small. Just trust me, it's the Traefik default cert. So for now, let's just leave the whole HTTPS side of things alone, and we'll concentrate on HTTP. We'll get back to this. Now, a moment ago, I told you that the Kubernetes ingress provider for Traefik Proxy is annotation-based, right? So to configure Traefik to only listen on specific entry points for this ingress, we add an annotation to the ingress resource that tells Traefik what to do. And I copied and pasted the wrong command. Really? That's terrible. All right. There we go. So kubectl annotate ingress Traefik dashboard, and the annotation that we're adding is telling it to only listen on the web entry point. Now, if we were to come back over here, it'll still give us a certificate error, but if we were to accept that to go past this, it would actually give us a 404 because it's not listening there. If we change this back to HTTP, well, then we're still good. And you can see now that the bottom router, the one that had the little shield there for HTTPS, is no longer there. We create middleware with a custom resource, and then we apply it to the ingress with an annotation. Because middleware is a custom resource, it exists within the Kubernetes CRD provider. An ingress is handled by the Kubernetes ingress provider. Since those are two different providers, they're in two different namespaces. So when we add the annotation to the ingress, we have to specify the Kubernetes CRD namespace to the middleware annotation. Also, because we're crossing provider namespaces, we have to include the Kubernetes namespace where the middleware lives. So in this example, we want to use the dashboard auth middleware in the kube system namespace under the Kubernetes CRD provider. Remember when I told you ingresses were a little clunky? Well, here's a sample list of the middleware that are available. These provide common actions for mutating HTTP requests and responses, but if there's something else that you would like to see Traefik Proxy do, you can create your own middleware and submit a pull request for us to include it. So we can't just leave the dashboard exposed like that. Even though it's read-only, it holds sensitive information about our cluster configuration, and we want to keep that information private. To do that, we'll add a layer of basic authentication on top of it with middleware. Go full screen here, I have to ask you another question. How many of you remember when basic authentication was the best that the internet had to offer? Some of you who've been around for a while probably remember configuring htaccess files to secure your directories with Apache. Now, basic auth seems cheesy. It seems almost like it's dirty. But it's actually a totally fine way to secure simple resources. Just remember that if you want to secure multiple different resources in multiple places with the same account information, then you should look into Traefik Proxy's support for JSON Web Tokens or the forward auth middleware that will hand off authentication to an external component that can then query a centralized IDP solution. Today, we're just about quick and dirty, so basic auth it is. Da, da, da. All right. Our middleware is going to refer, oops, I'm in the wrong directory. We're now in activity 2. Our middleware is going to refer to a secret that contains the users and their passwords. This file, which I just popped up here on the screen, is in the standard HT password format that's been used by web servers for decades. Each line contains a username and an encrypted password separated by a colon. If you're following along in the repo, you can just use that file. There are 2 users inside of it. Their passwords are user1234 and admin1234. You could also just create it with the HT password command or with an online generator. Once you have this file via whatever means you want, we need to create a secret that we'll just call dashboard users. That secret holds this users file in its data key. Ta-da! Now we can create the middleware that references that secret. The middleware looks like this. Middleware is one of the simplest resources you can have. Basically, in the spec, you declare the name of the middleware that you want to use and then any parameters associated with it. In this case, basic auth just needs to know the secret. We'll apply that to the cluster. And there we go. So now we have a secret. We have middleware that references the secret, and we need to tell the ingress to use it. In order to connect the middleware to the ingress, we'll add another annotation that tells traffic to use this middleware before sending traffic from the router to the service. So here you see a new annotation. Traffic ingress kubernetes.io router middlewares equals kubesystem dashboard auth at Kubernetes CRD. So that's kubesystem namespace, dashboard auth is the name of the middleware, and it's in the Kubernetes CRD provider. Now, when we visit the dashboard, it's probably already, interesting. Yes, it is already asking me for a password. Yeah, there we go. So we see that we're prompted. We enter a password, we enter that, and we're back in. And now it's secured. The dashboard listens on /dashboard/. Remember I told you that it's important that you include the trailing slash, but we're using a dedicated hostname for it. Now I, as a system administrator with a very, very long career behind me, believe very strongly in laziness. I am personally committed to typing as few keystrokes as possible. So I want to have Traffic Proxy just add that path for me with a rewrite before it forwards the request. We can do this with another middleware. And it looks like that. So we're going to call this dashboard rewrite, and we're going to use the add prefix middleware, and we just want to add /dashboard to whatever. Having created that, we need to add it to our annotation. When you're using kubectl annotate, if you're updating an annotation that already exists, you have to provide -- override equals true, otherwise kubectl will bark at you. So in this case, we're using our previous annotation plus the new annotation. We're actually starting with rewrite and then adding auth. And now it's annotated. Middleware order matters. Traffic Proxy will chain them together using the output of one as input to the next. So in our case, which one do you think should come first? I was actually supposed to put the basic auth middleware before the rewrite because the rewrite doesn't matter until our request gets forwarded to the service. If Traffic Proxy receives an unauthenticated request, then I would want to bounce it before we actually do any more work. But I didn't actually do that because I copied the command wrong. But that's how I would have done it if I was typing it manually. Now, if we visit the dashboard without a path, so up here, you can't see it, but I'm going to take out /dashboard, then everything's perfect. Uh-oh. Everything is not perfect. Huh. Well, I personally love when webinars become live troubleshooting sessions. So something here clearly is wrong. the images aren't loading, and how can we figure this out? Well, you just look in the developer console. So let's right click here, developer tools, inspect, and this is probably going to be smaller than you can see, but just trust me when I say, if we go to the network tab, then you would see these red lines. These are 404s for /API. Make that as big as I can. There you go, red lines appearing. It's terrible. We just added a rewrite rule so that everything has /dashboard appended to it. This means that, sorry, it's actually prepended. Everything has /dashboard prepended to it. So this means that /API is actually going to /dashboard/API, and that doesn't exist. The only way to fix this with the Kubernetes Ingress provider is to create another ingress that handles requests to /API and that doesn't have the rewrite middleware attached to it. So let's go do that. So there's kubectl create ingress traffic dashboard API. The rule now uses /API and still sends it to traffic dashboard. Now, oh, look at that, it's already back. But you see that there's still some stuff missing. Well, those aren't dynamically reloaded. So if I reload the page, you actually get everything back and everything looks good. This is another example of how the Kubernetes ingress is limited. Having to create two almost identical ingress resources is fine if we're only working with one application, but it's just a clunky way to solve the problem. As much as I believe in laziness, I also believe in elegance. So let's move on to using Traefik custom resources so that we can solve this more elegantly. An ingress route represents a traffic router. There are three of them: Ingress Route for HTTP, Ingress Route TCP, and Ingress Route UDP. The Ingress Route contains a match directive, and when I say Ingress Route, I'm just referring to the whole family of them. But it contains a match directive that allows us to build arbitrarily complex rules for how we want to match traffic before acting on it with the instructions that follow. Obviously, you can do a lot more with HTTP. In a situation where multiple rules match, the default is to prefer the longest rule. So this is usually safe. If you think about it, a match on /API is more specific than a match on /. So /API is longer, and that's the one the traffic will prefer. The place where it's not always true is if you're working with regular expressions. And if you find yourself in a situation where the wrong rule is matching because it's longer, you can manually set rule priorities with numeric values, and the highest numeric value wins. They're totally arbitrary. They can be 1 and 2, 35 and 70. It doesn't matter. The first thing that I need to do, since we're going to go from ingresses to ingress routes, is I need to nuke the two ingresses that we just created. Done. Next, I'll create a new ingress route that combines both paths and the middleware into a single resource. First, let me show you what that looks like. It looks like that. So you see in the spec, we specify the entry points, and then we actually have two routes. So kind as rule, one matches on just the host name itself. The other one matches on the host name plus the prefix. The first one has middlewares for, oh, did I say middlewares? That's it. It's over. The first one has middleware for dashboard auth and rewrite, and the second one only has middleware for dashboard auth. Let's apply that. And now, how many of you are wondering, what do we call that? We call that Traffic Dashboard Secure. How many of you are wondering why it's called that when it's listening on port 80 and sending passwords over plain text? If that thought has popped into your head, you get bonus points. But we're going to fix that in the next section. When we visit this dashboard again in the browser, it looks exactly the same. Because we didn't really change anything. We just changed how things are happening. So it works exactly the same. We secured / and /API with basic auth. We have a rewrite. It sends it to /dashboard. It's fine. But another question is, why didn't I just call it Traffic dashboard. Doesn't it seem like anti-lazy for me to add -secure to it? Well, it turns out that there's already an ingress route called Traefik Dashboard that's installed with Traefik. So let's go take a look at what that thing is doing. Look at Ingress Route. Oop. Helps if we tell it that we want YAML. All right. This is listening on the Traefik entry point, which is port 9000. It's handling /dashboard and /API, and it's routing it to a resource that we have not yet seen in action, which is a Traefik service called API at internal. A Traefik service is different from a Kubernetes service. It's the CRD implementation of a Traefik service in Kubernetes. When we configure an ingress route to send traffic to a service, if the kind key is not specified, then the name defaults to a Kubernetes service. We use a Traefik service to control how client requests are load balanced across backend servers, or in this case, to route to a special internal Traefik endpoint, the API. This ingress route is how traffic to port 9000 finds its way to the dashboard. If I remove it, well, then the dashboard actually completely disappears. So it must be important, right? But a lot of its configuration overlaps with our own. In fact, this is how our routing happens. We're sending our traffic from port 80 up to port 9000. And we're really going from an ingress route to another ingress route only to end up at the API internal service. Now, what happens if we patch our ingress route to go directly to API at internal and cut out the middleman? Well, that would be a whole lot more efficient. We can do that. Let's actually show you the patch. By simply changing our ingress route, by changing both rules to send to the Traefik service of API at internal. And now if we go to the browser and we reload, everything looks exactly the same. Except now, if we look at the routers, you can see that we're going to the API at internal service for our two rules. With that done, we can actually remove our service object entirely. Totally lost my train of thought. We visited the dashboard. We see that it works. This is a much more elegant and, where's browser? That's the tab I want to be on. This is a much more elegant solution, but you might be wondering why I didn't just edit the Traefik dashboard ingress route directly. I could have absolutely done that, but that ingress route is controlled by Helm, which means that if we edit it directly, we don't actually know that our changes won't be clobbered by some future upgrade or some other change. In my opinion, it's better to just leave it alone and also leave it unused. It can answer requests that come into port 9000 from something else if something needs to use that in the future, and we just create our own ingress route that does exactly what we want it to do. Let's talk about TLS. The command line options for K3s activate TLS support for the web secure entry point. We saw this when our ingress automatically responded on HTTPS with the default Traefik certificate. If you install Traefik from the Traefik Labs Helm chart, well, TLS is not active on any entry point. That doesn't make any sense. Why would they do that? It does make sense. Remember, entry points are protocol independent. If you activate TLS globally on an entry point, then all routers on that entry point have to terminate TLS. If no certificate is provided, then the default Traefik cert gets used. If you're doing TCP pass-through to a backend with its own TLS certificate, then it's better to just pass the TCP stream directly through. The only way to do this is if you don't activate TLS on the TCP router. What you do is unique to your environment. Traffic proxy is flexible. In the case of K3s, they're just turning it on because people expect 443 for HTTPS to have a certificate of some kind, but you do what you need to do, and Traffic Proxy will support you in that. It's the same way that Rancher supports you in your Kubernetes clusters to do whatever it is that you want to do. It's not about telling you what to do, it's about giving you the tools to do it. So if you know that port 443 is always going to serve HTTPS, well then just activate TLS on that entry point and be done with it. But if you want to have more granular control over encrypted traffic, then activate it on the individual routers. As I said earlier, the configuration that we've just created is completely insecure. We're accessing data over HTTP, we're sending our credentials in plain text. If my mom saw this, she would totally wag her finger at me and say, that just will not do. And my mom does not sound like that, but whatever, you get the point. We want to wrap our communication in TLS encryption, and for that, we're going to generate certificates with Cert Manager. But first, wait a second. Hold on. Doesn't Traffic Proxy come with support for Let's Encrypt? In the non-Kubernetes world, integration with Let's Encrypt within a container orchestrator is challenging. It's difficult. It sucks. Traffic Labs solved this by building support for Acme certificate generation into Traffic Proxy. Let's Encrypt is an Acme provider, so yes, there's Let's Encrypt support, but it just supports Acme certs. Certificates are stored in a file called acme.json. And if you think about how Docker works, storing this file on a persistent volume is easy. In fact, if you don't have that file, then you restart stuff, then it just recreates all the certificates, which is fine if you only have a handful of certs, but is not fine when you have 15,000 like one of our customers does. Now, Traffic Proxy works the same everywhere, which means that in Kubernetes, the Acme support still writes out to acme.json, but putting this on a persistent volume introduces new challenges. For example, do you pin Traffic Proxy to one host by using a local volume? You could. If you want to run multiple replicas, can you mount it read-write many via NFS? What if you don't have an NFS server? Even if you do have an NFS server and you run multiple replicas, does Traffic Proxy handle file locking, or will each replica clobber the file that was written by the others? Spoiler, it doesn't do locking. It's going to clobber stuff. These are not new problems, and the solution for Kubernetes is to store each certificate in its own secret. Unfortunately, because Traffic Proxy works the same on every orchestrator, and because every orchestrator doesn't have a secret resource, Traffic Proxy doesn't yet store certificates and secrets in Kubernetes. But it's not the end of the world. It can read certificates from secrets in both the Ingress and Ingress Route resources. So for that reason, and to make sure that you can spin up new replicas before shutting down the old ones, I recommend that you use Cert Manager to generate certificates in Kubernetes. Terminal, too many buttons. We're getting to the manic portion of the webinar. Now, this isn't a class on deploying Cert Manager, but if you're in the READMEs, you can actually see that I go through a whole thing about Cert Manager and cluster issuers and HTTP 01 or whatever, but I already deployed it in my cluster just so that we can get past that part. Remember, we're using a hostname that resolves to the private IP of my cluster and hopefully the private IP of your cluster, and this cluster doesn't exist out on the internet. So that means that the HTTP 01 solver won't work. I could use the DNS 01 resolver instead, but I want the instructions that you're following to, in the README, I want those to work for you with minimal changes. Since this is a demonstration, I'm not going to get all hung up on using real certs. I'm just going to have Cert Manager generate a self-signed certificate. And that shows off all the moving parts without having to worry about the details of real hostnames, public IPs, dynamic DNS providers. I don't want anything to get in your way. So let's show you first a simple cluster issuer for a self-signed certificate. It looks like that. It's so easy. We'll apply that. And now we can generate a certificate. What does a certificate look like? It looks like that. It says, what's the common name? And where do we want to store it? And which issuer do we want to use? Easy enough. Let's create that. And now we've created a certificate that's stored in the dashboard-crt secret. It's possible with Cert Manager to have certificates generated automatically through annotations on the Ingress resource. But not only are we not using an Ingress resource, personally, I want to have control over the resources that my cluster generates. I do a lot of stuff with GitOps. I like knowing what's happening and being 100% sure that I can duplicate it in another environment. So instead of creating it, I like to use certificate resources. To use the certificate that we just created, we need to make 2 changes to our ingress route. Let me show you that patch. First, we need to change the entry point from web to web secure. And then we need to add a TLS key that points to the secret where our certificate is stored. Done. Now, when we visit the dashboard over HTTPS, we'll be greeted by the, oh no. Okay, good. So there's a 404 because we're no longer listening on HTTP. We'll fix that in a second. But now, your connection's not private. Oh no, it's the end of the world. Let's look at the certificate. Before it was the Traefik default certificate. And now you can barely see that it now says dashboard.traefik.myip.sslip.io. Okay, cool. So let's accept this warning. Okay, this is ridiculous. And by ridiculous, I mean fun. If you're using a Chromium-based browser, so that's Chrome, Vivaldi, Edge, I'm using Vivaldi, you'll get an error that the certificate data is scrambled and you've been saved by the browser from a terrible fate. In fact, it's so annoying. You cannot visit this because the website sent scrambled credentials that Vivaldi cannot process. No, it's just that Chromium is being too prescriptive. This is a family-friendly show. The way to fix this is you literally type "this is unsafe," all one word, just over the browser window, and it just reloads. There you go. So your trick for the day. Now, we can see that we're now visiting it over HTTPS, so our authentication is secured. You can see now that our 2 ingress routes here are secured by TLS. They've got the little shield going, and that's cool. But we don't have anything listening on HTTP. And you saw that when I reloaded and it said 404. Okay, well, let's create a new ingress route and middleware that bounces HTTP to HTTPS. So here we have a simple ingress route, but this one has a middleware. This one will use a middleware called Redirect Permanence. That is from the scheme, the redirect scheme middleware, which will redirect from HTTP, which is a scheme, to HTTPS. And we're telling it to also use a permanent redirect. So we create that. And then we create the ingress route. And now, if we were to go back to the HTTP version, it will instantaneously redirect us to HTTPS. This is all well and good, but what did we just do? We just secured the dashboard for Traefik. Now, what I just showed you doesn't just apply to the dashboard. I just chose that because it's a useful application, it's already there, and it allowed me to teach you about entry points, routers, services, ingress annotations, ingress route and traffic service CRDs, middleware, and TLS. That's a lot. Like, that's a whole lot of stuff. And you can take that information, you can use it with any of your applications. And to show you, here's an example of something that I'm personally running. I need to make this as big as possible, so I'll take myself off the screen. Out in Linode, I have a single node K3s cluster running my mail server. I use the Axogen mail server. I've run my own mail server for years. I just switched from using Postfix and Dovecot and a bunch of stuff to Axogen, which is, they have a free tier. If you run your own mail server, check them out. It's wonderful. So it runs my mail server. Traefik Proxy handles HTTP, HTTPS, and TCP traffic for secure SMTP and IMAP with middleware in place for rate limiting. I'm also running a sidecar with Tailscale. That sidecar connects to the Tailscale Mesh VPN for all of my systems, so traffic can connect back to a 5-node K3s cluster that's running here in my house. Here in my house is where I run websites and other services that I want to have appear on the internet. Their host names terminate on the traffic proxy address out in Linode, and they're backhauled over a TCP ingress route to my house, where they're then routed to local services running either inside or outside of the cluster. Traffic also handles HTTP and HTTPS for the local network via split DNS. So if I want to connect to something locally, my request doesn't have to go all the way out to the internet and then all the way back in for something that's right in the next room. Through that same Tailscale sidecar, I also connect to my property in Chile. Some of you might know that I lived in Chile for the last 8 years and I just moved back to the US last May. So back in Chile, I have a pair of Mac Minis that are running K3s on Debian. I use that cluster to monitor the 12 kilowatt solar installation that's running down there so that I can make sure that it's working correctly until that property sells. Altogether, it looks like this. Linode in San Francisco and my house in Chile are edge locations. My house here in Las Vegas is the primary location. All of these locations run K3s, and connectivity between them is handled by Traffic Proxy and Tailscale. The effect of all of this is that I was able to cut my cloud bill from around $300 a month down to around $15 a month. And that's money that was coming out of my pocket. I know businesses, and those of you who are watching that work for organizations, you have huge cloud bills, but with a solution like this, you can decide where your resources are going to live. And if you want to see in detail how I did this, I made a pair of videos that document the entire process. They're available on YouTube at adrian.goins.tv. That'll redirect you. Let's talk about troubleshooting. One of the things that people complain about when using Traffic Proxy is that because of its dynamic configuration, it uses HTTP response codes to tell you about problems. These are totally compliant with internet RFCs, but that doesn't make them any less confusing. And that's largely because you don't know if they're coming from traffic or from your application. When you start working with Traffic Proxy, or if you've already been working with it, you're going to run into these and they're going to make you mad. I know, they made me mad. So I want to give you some information that will help you sort through them. First, look at the container output in the Traffic Proxy pod. It will often tell you if it can't find something. You can also enable debug logging in the command line options, and this can give you more information. I ask that you always apply sane troubleshooting practices. When something stops working, the first thing I ask myself is, what changed? And no matter how much I think that a particular thing couldn't possibly have created a problem, I look at it anyway. And more times than not, that's the problem. The 3 response codes that you're most likely to see are 404, 502, and 503. A 404 can mean that an entry point has no routers. It can mean that a router cannot be matched to a service, or that a configuration component like middleware can't be found. Think about what a 404 means. Something wasn't found. A 502 is an error that happens when contacting an upstream service. So it means that there's a problem with the service itself within Traffic Proxy. Traffic Proxy generates a 503 when it actually tried to connect to your backend servers, actually connect to your application, and either no servers are available or no servers are healthy. And now, we take questions. Robert. Robert fell asleep.
I did not. That's not fair. I was waiting for you to just finish talking. You were like a madman there for a minute. Well,
yes. Did we have any other audio issues, or was everything good?
The audio issues were fantastic. So I actually have all the questions up here. The chat has been on fire. I haven't seen a chat session this deep. So normally, chat's like, I'm the only one talking. This group of individuals, I have to give them credit. They have been on fire. We have about 12, 13 questions in the queue. So I think I'm going to start, launching them off here. The top one is, can the Helm chart and Helm chart config CRDs be used with other K8 distributions like RKE2?
Okay. I don't know for sure if RKE2 includes actually, yes, RKE2 does contain the Helm chart controller, so you can just use them. The directory is different. It's var lib rancher RKE2 server manifests instead of var lib rancher K3s server manifests. RKE does not include it unless they've added it, and obviously other Kubernetes distributions haven't, but the Helm controller itself can be installed in other places. So if you wanted to use that with whatever else, then yeah, you can get it off of GitHub and install it. If you are using GitOps in your Kubernetes environment, you may also have something already. For example, Flux v2 has a Helm release custom resource that does basically the same thing, but doesn't have oh, actually, you know what? I just answered the RKE question incorrectly. The server manifest directory is not the Helm chart config, but I believe that RKE2 also contains the Helm chart resource. Anyway.
Okay. All right. Here's this question got a lot of votes. Is there somewhere I can get Traefik training / mentorship?
Wow. Yes and no. Some of you, if you've done work with Rancher, remember the Rancher Academy. Prior to SUSE acquiring Rancher, there was the Rancher Academy. It was covered Rancher 2.3 and was taught by me and William Jimenez, also from SUSE. I am building something similar for Traefik Labs. In fact, after this, I'll be taking this, and this is going to be the first mini course, but I will also be building a more comprehensive certificate. I'm going to build something else that when you're done with it, you'll get a certificate. I'm not sure how to say that eloquently, but yeah, look for that coming in the next few months.
Okay. All right. All right, next one. What is the recommended approach for blue, green, and Canary deployments leveraging Traefik's capabilities, or use service mesh Istio / Kong for that?
Okay. So I can answer that in a couple of different ways. You can do blue-green deployments. This is interesting. Okay, so technically a blue-green deployment is you have a complete deployment somewhere. Blue-green, AB, Canary, they kind of all overlap. So blue-green deployment is you have a production environment here, and then you deploy another one over here, and then you just, you fail Traefik over to it. So you can do that with Traefik Proxy by having your two environments with Traefik services or regular Kubernetes services sitting in front of them that have different names, and then, so they could be different namespaces, they could be different deployments, however you want to segment those. And then in the ingress route, you simply change the target to point from service A to, well, service blue to service green. And then when you can fail it back. Now, if you want to do a testing type, like a Canary style, you can set up weights within a Traefik service. So then the Traefik service has the two targets, and you say 90% of my traffic goes to blue and 10% goes to green, and then you can manually adjust that until it's 100% and 0. Traefik Proxy does not currently, and I say currently because we have something coming that will do this, but it's not out yet. I can't talk about it, but it's coming, that will do that progressive migration for you. If you needed that today, though, then you'd want to look at something like Argo rollouts, or something that can handle that phased migration.
You're not going to give us a sneak peek of that? A little teaser? No?
I cannot. I'm sorry.
See, I've reached out on the behalf of the community. I was trying to get them to answer that.
Yeah, it's in private beta, and there's a lot of work. There's a lot of work going on it. I can't. But when it happens, you'll see me out there waving a big flag.
When it happens, would you come back and talk about it?
Oh, absolutely. I would love to if you would have me.
Of course I would. Don't kid yourself. Okay, next question, my dear sir. Is there a way to deploy RKE cluster with Traefik, and I believe it's Traefik Proxy? I understand that there is a Helm chart, but that would be a post deployment. So I think they're asking if this could be pre-deployed with it, if that's possible.
Yeah, that's. Make a note of who asked that. So here's what I would like. I would very much like that to be the case. K3s ships with Traefik, and right now RKE2 ships with the hardened version of Ingress Engine X. RKE2 has special special requirements because of its secure nature. But I would very much like to see RKE ship with Traefik instead of Ingress Nginx. I am gently probing how interested SUSE would be in doing that as part of the partnership that Traefik Labs and SUSE have. We are very, very preliminary in those discussions. But if that is something that anybody in the community would like to see, please open a GitHub issue on RKE, on RKE2, making that request, and everybody just go and upvote the heck out of it. And that will help me in my quest. As a stopgap measure, we will be getting documentation out, hopefully within the RKE and the RKE2 documentation that explains how to deploy Traefik Proxy. But yeah, I want it there by default as well.
All right. Next question. Can we redirect SSH connection over Traefik?
Okay. So the use of the word redirect implies that you are able to do something based on the connection. And I don't think that's what you mean. It's not like you want to receive an SSH connection on 443 and redirect it to port 22 or something like that, because SSH won't work like that. If you mean, can you proxy an SSH connection? Absolutely. You absolutely can. You can proxy it with, to an external server. You can't have like a single port 22 that you then like load balance across multiples, because that wouldn't work. You couldn't have a single port 22 that like is then able to select which server it connects to, but you can absolutely tunnel port 22 from or any other port from a Traefik proxy instance or a node running Traefik proxy back to some other server. Totally.
All right. Next question. Is there a Traefik certification? And I think you might have answered this before, that it's in progress.
It's in progress. Yeah, I'm working on the Traefik Academy, and that will include a certification. Absolutely. So you'll be able to put up on LinkedIn that you have a certification from Traefik Labs, that you passed the exam. Any of you who've been through the academy know that like this was no joke. We had a 200 question pool. Your final exam was 50 questions randomly from that pool, and lots of people failed it. And then they went through the course again, and then lots of people passed it. It is a testament from the organization. In the case of the Rancher Academy, it was Rancher. It'll be the same with Traefik, that says we have trained you and tested you, and we are confident that you are able to execute the functions of an administrator of Traefik Proxy. You'll get that in the next few months.
I was a fan before I was an employee, and I actually failed it too. So anyone who's failed that, don't
feel bad.
Don't feel bad.
Yeah, failure doesn't mean anything bad. It just means that you don't yet have the knowledge. And the thing is, you want the knowledge. Like, you want to be able to go into an environment and confidently execute on the knowledge that you have. Like, I don't have a Kubernetes certification. It's something that I've been just sort of poking at, and I know that I need. I know that I know how to use Kubernetes, but I also know that I know how to use Kubernetes in the environments that I'm in. And there are parts of Kubernetes that I've never encountered and that I don't know how to do. The certification exposes that, and it shows me where I need to get additional training to be comprehensive in my skill sets. I mean, who doesn't want that? So failure is never bad. Failure is just, it's like taking your temperature and then shows you, like, temperature is maybe a bad example. It just shows you where you need to learn more.
All right, so let's see here. Any good tutorials for WebSockets with Traefik?
Traefik will just dynamically pass through WebSockets. You don't have to actually do anything. So if the thing that you have on the back side of it speaks WebSockets, then Traefik will see the upgrade header come through, and it will upgrade the request, and it'll just do it.
Okay. Should Traefik Proxy dashboard work with Rancher Desktop? Good one.
Yeah, I don't know. Rancher Desktop installs K3s. The dashboard is there, so yeah, it should. Yeah. I sound like the guys from Wayne's World. Chaw.
Chaw. That was more Napoleon Dynamite. God. Remember that?
Oh, yeah. I just watched Blades of Glory the other night. It was the same actor in it.
That is a great one.
I have Kubernetes skills. I have nunchuck skills.
I got Traefik skills.
Skills.
Simon, this should work, because Simon's one of our I'm gonna say repeat offenders, but he's always with our events, so he's a regular. So try Simon, that should work.
Nice.
I'm gonna try it right afterwards because I'm kind of curious. Yeah. I'm gonna give it a whirl because I have Rancher Desktop installed 1.0.0.
So Rancher Desktop is a little special because all of the stuff that it port forwards is directly off of localhost. Mm-hmm. So if you're trying to access it like as cluster IP or whatever, because depending on where you're running it, you may not have access to the actual IP of the virtual machine that's running the cluster itself. Like on Mac, you don't. So you should be able to, at the very least, just do the port forwarding. So change over to the kube system namespace, and then port forward the Traefik pod on port 9000, and then connect to localhost 9000, and you should just get the dashboard. Beyond that, setting up ingress routes and stuff like that. Actually, that would also still work. The thing is, you can't just go to localhost because localhost it doesn't have the host header to route. So you'd need to create, put something in Etsy hosts that, here's what you can do. Oh, here you go. Just set your cluster IP in the variables, just set it to 127.0.0.1. And then you would just go to dashboard.traffic.127.0.0.1.sslip.io. And it should just work. That'll be the host header. And as long as you set that in the ingress or the ingress route, then yeah, you'll be fine.
Okay. All right. Is the dashboard possible with K3s since the Traefik is already installed?
Yes, it's there. You just have to, it's not attached to the service by default. So you either have to port forward it like we did in the beginning, or you have to go through the steps to create a new service. Or if you follow through in the GitHub repo, and you can just jump down to the ingress routes portion of things and just go from there down, and everything will work for you.
All right. This one got a couple of upvotes, and I'm going to. I'm going to answer this one real quick. Is there a Slack channel we can go to for support for Traefik or community support? And Adrian's going to show a slide at the end where you can learn all that information. So we're not going to talk about it right now. So wait a few minutes. We'll get to that slide. It's actually a very important slide. I think it's probably one of the most important slides that he's going to show today. So
that's right. So don't drop off early.
Hey, listen, if you drop off early, you lost out on a lot of good information.
We have your email address. We'll
just email
send you
too.
Email.
Is it possible to get Traefik for Rancher? For Rancher clusters out of the box? I think.
Okay, is it possible to get Traefik for Rancher clusters out of the box? If you install K3s, yes.
Yes.
Otherwise, you would have to install. For example, if you deploy RKE, there's an option to not deploy an ingress controller if you're doing it from within Rancher. And so if I want Traefik, I just check or uncheck that, whatever. Say don't deploy an ingress controller, and then afterwards I just install it via Helm.
Okay. All right. Done answering this one. Let's see.
These are great questions. Thanks. My thanks to all of you for being so engaged.
Normally, it's not this busy, so you should feel special. You should feel honored because normally it's not this busy.
Dude, I'm just excited that I am just like all of you. Like I told you in the presentation, I for years I tried to use Traefik. So here's the thing: when you're building a new cluster, that's the time when you're like, okay, I'm just going to swap out to a different ingress controller or an API gateway or whatever, just to see what these things are. But your objective is not to learn how to use a new API gateway. Your objective is to build a new cluster and then start using it for whatever you're building it for. So the more friction that exists in that process of learning something new, the less likely you are to do it. Traefik's friction at the very beginning is quite high. I understand that. And I've gone through it now, and I realize that what appears to be an insurmountable hill is actually, it's not insurmountable at all. And once you get to the other side, it's like a beautiful, bountiful green wonderland of delicious whatever. It's everything that you want it to be. You've seen what Traefik Proxy can do. You already have it there. It's just about learning the lexicon, and then so the vocabulary, entry points, routers, services, and what they map to. And then, well, basically everything you saw today. So in this 1 hour or whatever we've been, oh my gosh, it's been more than an hour. Oh my gosh, where I have to go soon. In this class, you have everything that you need to start using Traefik Proxy. And
All right, so we're going to go through these questions quickly here because I want to respect everyone's time. Why can't I use a service name instead of a port number in the service section? And this is in the Ingress Route, and it's from Oliver here in the community.
Why can't I use a service name okay, so that's a traffic service. Okay. So, all right, so here's an example right here that's using a Kubernetes service. So you need to have the name and the port, and that's because a Kubernetes service can listen on multiple ports. So just sending it to the name, this isn't a traffic specific thing. Sending it to the name isn't enough to clarify where it actually needs to go. So you have to also include the port. I think that's what you're asking, I hope.
Okay. All right. I actually had to full screen that for you so they can see what you're seeing. All right. Here's a great question. Where can I get a traffic t-shirt like Adrian's? I don't even get one. Like, really, guys? Like we're friends. Him and I are friends. We're cool. I don't even have. I don't know.
You want
Adrian?
one? I'll hook you up.
I got some Rancher shirts if you need some.
Actually, all my Rancher shirts are all ratty because they're old. I have some nice SUSE shirts still. Where can you get a traffic t-shirt? Blah. Okay, you're going to see, so we can get you a traffic t-shirt. If I'm trying to think of what the best way is for you to find me, there'll be a slide later on that tells you how to get help, and one of those places is in our Discord server. In my Discord server. I said our because Rob also hangs out there. And so if you join that and ping me, and Rob, just make a note of who this person's name is. Obviously, we can't give traffic t-shirts to everybody, but I can see what I can do, and I'll talk to our community manager about that.
All right. Is it possible to have a router point to a server on a VM, in addition to having routes into K8 pods, as you have shown?
Okay. Yes, absolutely. So I can't quickly show it to you, but in my local environment, so traffic comes into Traffic Proxy in my Kubernetes cluster, and then some of the things that it's actually sending out to are on other VMs in my environment. I run Proxmox here. So like, what, MQT? No, MQTT is in there. I have other stuff that's on VMs, and the only trick to that is you still need, in the Ingress route, you still need to send it to a dummy service that traffic will never get to because it's actually being redirected out. But you need that in the Ingress route, so you can put you put anything there. It doesn't matter.
All right, guys, we have a few minutes left, and I'm going to be respectful of everyone's time. We've been going strong for over an hour and a half, almost an hour and a half. If your question has not been answered, I'm going to ask you that you post your question in community.suse.com, and we will get this answered either today or tomorrow. Or you can ask it in, well, Adrian, how about you share your final slides and tell people how they can, join some other communities too.
We'll give you lots of places that you can go and post stuff. All right, go ahead and full screen me.
Yes, sir.
Bang. And now, next steps. So as I said a minute ago, you now have everything that you need to start using Traffic Proxy with K3s or any other Kubernetes distribution. But, I mean, come on, the fun doesn't stop there. This is fun, right? Rob, is this fun?
I'm having a blast.
Yeah, like I love working with technology like this. It makes me feel like a wizard, like I have magical powers because I can, it's fun, and it should always be fun. We released Traffic Proxy 2.6 on January 25th with updates for the new Kubernetes Gateway API that's one day going to replace Ingress altogether. It also includes advanced health checks for HTTP 2 and enhancements for HTTP 3, along with the first phase of support for console enterprise namespaces. And in fact, there's a free webinar on the 2.6 features this Thursday at 8 a.m. Pacific, where one of our engineers will be demonstrating these features live and answering all of your questions. So you can get that from info.traefik.io/en/Traefik 2.6 features webinar. You can probably go to our webpage and find it under an events page as well. Two other open source solutions that you can look at for your Kubernetes clusters are Traefik Mesh and Traefik Pilot. Mesh is a simple service mesh that lets you secure and control intra-cluster traffic that doesn't go through Traefik Proxy. It doesn't use sidecars, so it's both lightweight and non-intrusive. Pilot is a free SaaS solution that gives you extra visibility into the performance of your Traefik proxy, and it activates an engine for plugins that act like middleware. There's a marketplace for plugins, and there's documentation on how you can create your own. Plugins are a powerful add-on for Traefik Proxy, and in fact, when everyone was scrambling to fix Log4j, we released a plugin that blocked the Log4j scanners at the edge of any network that was running Traefik Proxy. So this protected vulnerable environments from attack and gave them the time that they needed to upgrade their applications. Now, when you need a helping hand, we're here for you. You can find community support in the Traefik community forum at community.traefik.io or in the SUSE and Rancher community at community.suse.com. You can also browse our documentation at doc.traefik.io. And you are all invited to join the 500 other Kubernetes enthusiasts in my personal Discord server at llb.io/discord. Now, Traefik Labs doesn't have a Slack environment. They have the community forum. But if you want some more real-time chat, just come hang out with us in Discord. I told you at the beginning that I would show this slide at the end and that I would hope by the end I will have gained your trust and interest. My name is Adrian Goins. I want to thank you for joining me today. I hope that I've answered your questions about how to get started with Traefik Proxy and K3s, but if I haven't, come find me and I'll do my best to get you the answers that you need. And with that, Rob, we can wrap it up.
All right. Well, thank you, Adrian. Really appreciate you coming back, and we look forward to having you back once again. For everybody else in the community, thank you. This has been a great session. We do appreciate it, and we'll see you guys in the community. Take care.
Take care, everybody.